Ever thought about how the whole story of Earth actually ends? Maybe not, a big Hollywood explosion, but more like a slow fade.
Hmm.
Because apparently supercomputers have looked way, way into the future, and they've come up with a timeline for the end of life here that's, well, surprisingly specific.
Yeah, it's pretty mind-bending stuff.
Welcome to the Deep Dive. We dig into the research so you don't have to. Today, we are looking at the scientific forecasts for, well, the ultimate end of life on our planet.
That's the plan. We've got a couple of really interesting articles guiding us. One gets into some heavy supercomputer modeling NASA and University of Toho scientists looking billions of years out.
Billions, okay.
And the second one, it looks at threats to the atmosphere, both like right now and over those huge timescales.
Right. So our goal here is pretty simple. Pull out the key stuff from this research, give you a clear idea of the timeline, what causes it, without drowning you in data.
Let's get into it.
Okay, so that headline finding, the big number from the supercomputers, it's pretty stark, isn't it?
It really is. The models basically point to the end of complex life around the year. Wait for it. 1 billion, 2021.
1 billion. I mean, that's just, it's almost impossible to really grasp, but they sound quite certain.
Well, as certain as models looking that far ahead can be, yeah. It's based on some pretty fundamental physics about our star.
And the culprit isn't some, rogue planet or alien invasion.
Nope. Much closer to home. It's our sun.
Our sun. Okay, how?
Basically, over the next billion years or so, the sun just naturally gets brighter and hotter. Its energy output increases.
Right, stars evolve.
Exactly. And that gradual heating eventually pushes Earth past the point where liquid water can stably exist on the surface. Game over for life as we know it.
And the models say this is slow. Not like one Tuesday everything boils.
Definitely not. It's projected as a slow, irreversible decline. Think gradual baking over millions of years.
Huh. Which is maybe more unsettling in a way. But, okay, the research suggests we'd see signs long before that final billion-year mark, right? It won't just be fine, then suddenly gone.
That's a key point. The models predict sort of early warning signs. Things like oxygen levels starting to fall, temperatures climbing exponentially eventually, and just general air quality getting worse.
Okay, now this is where it gets really interesting for me, because the other article ties this long-term stuff to things happening now. It talks about solar storms, coronal mass ejections. We just had the biggest one in 20 years, right? How does that connect to a billion years from now?
It's a fascinating link. These big solar events, they blast particles at us, interact with Earth's magnetic shield, and they can actually strip away some atmospheric gases, including oxygen.
So tiny amounts get lost each time.
Tiny amounts, yeah. But the idea is that what we see now, this increased solar activity, is like a miniature version, a small taste of the kind of atmospheric pressure the sun will exert much more intensely in the very distant future. It's a glimpse of the long-term mechanism.
Wow, okay. And that second article also flags some more immediate atmospheric worries, things happening on a much shorter time scale.
Absolutely. It brings up things like space debris. Apparently, thousands of tons of old satellites and rocket parts burn up, re-entering every year.
And that releases stuff.
Yeah, pollutants like aluminum oxide. They even mention a specific big piece, Cosmos 482, expected down around 2025. Plus, the immediate impacts of solar storms on, satellites, power grids, communications.
Right, things we actually worry about day to day sometimes.
And of course, the big one, rising CO2 levels. Over 427 parts per million now. Which is, the main driver of our current climate change issues.
But there was a weird twist with CO2 in the upper atmosphere, wasn't there? Something counterintuitive.
Yes, that was really interesting. While extra CO2 warms the surface, it actually causes the very, very top layers of the atmosphere, the thermosphere, to cool down and contract.
Cool down? How does that work?
It's complex, has to do with how CO2 radiates heat away into space up there. But the effect is, if the upper atmosphere cools and gets less dense.
There's less drag on things orbiting, like space junk.
Exactly. So, ironically, our CO2 emissions might be making space debris stay up there longer before it naturally decays and burns up. A strange side effect.
Huh. Okay, so lots of shorter-term pressures. But let's circle back to that billion-year oxygen problem. How does the sun getting hotter actually kill off our oxygen?
Right, so the mechanism detailed in the second article ties back to the sun's increasing luminosity. That intense energy over long timescales will start breaking down CO2 molecules in the atmosphere.
Okay, breaking down CO2.
Yeah.
But CO2 is plant food, isn't it?
Precisely. CO2 is absolutely crucial for photosynthesis, the process plants and algae use to make their food, and release oxygen as a byproduct.
So less CO2 means.
Less photosynthesis, which means less oxygen being pumped into the atmosphere, a slow starvation of the oxygen cycle.
And this isn't necessarily gradual the whole way. You mentioned something about speed.
Yeah, the research suggests that once CO2 levels drop below a certain critical threshold for photosynthesis, the decline in oxygen could become really rapid, maybe plummeting over as little as, say, 10,000 years.
10,000 years on a billion-year scale, that's practically instantaneous. What happens then?
Well, it's grim. With oxygen levels crashing, the ozone layer, which is made of oxygen, O3, collapses. So intense UV radiation floods the surface. At the same time, other gases like methane might build up because the chemistry of the atmosphere changes so drastically.
Making it doubly uninhabitable. Okay. So, given these huge natural slow-motion forces, what about us, our impact? Does human-caused climate change matter in this billion-year picture?
It's a really important question. The researchers definitely acknowledge it. While the sun is the ultimate long-term driver, our current activities are clearly accelerating some negative trends. Faster warming, melting ice. We could be making conditions pretty tough much sooner than that billion-year clock would suggest on its own.
We're adding our own pressure to the system.
You could say that, yeah. We're kind of giving the planet a fever that complicates its long-term health prognosis, even if the ultimate cause of death is different.
Right. It's a sobering layer on top. But even with this long, slow decline being inevitable, the scientists talk about preparation, adaptation. What does that even look like?
Well, on the extreme long term, some talk about technological fixes, like could future humans, or whatever we become, build totally enclosed life support systems? Artificial habitats, basically bubbles of life support.
Sci-fi stuff.
Pretty much. And then there's the even bigger picture, getting off the planet altogether. Space colonization, the work NASA and SpaceX are doing regarding Mars, some see that as the first tiny steps towards ensuring human survival beyond Earth's eventual expiration date.
Spreading our eggs out into more baskets, which actually connects to another fascinating point they raised about looking for life out there.
Yeah, this is a really cool implication. Finding that Earth's oxygen-rich atmosphere is likely just a temporary phase in its life. Well, that shakes up how we search for alien life.
How so?
For a long time, the assumption has kind of been, look for oxygen. Oxygen means photosynthesis, means life. But if oxygen is only present for maybe 10–20% of a habitable planet's total lifespan,
then we might be missing life on planets that are younger or older or just different.
Exactly. Maybe life exists just fine in low oxygen or no oxygen atmospheres. Or maybe we'll find planets that are teeming with microbes but haven't hit their oxygen area yet or are long past it. It forces us to think much more broadly about what a living planet looks like.
So scanning the skies just for Earth twins might be too narrow. Okay, let's try and pull this all together. What are the big takeaways from digging into this future forecast?
Okay, I'd say. 1, the big driver for the end of life ultimately is the sun getting hotter over about 1 billion years. 2, this end will likely be preceded by major atmospheric shifts, especially a long-term decline in oxygen.
Driven by that CO2 breakdown.
Right. 3, we're potentially seeing tiny hints of future atmospheric stress now with increased solar activity. And 4, while the billion-year timeline feels remote, more immediate issues like space debris, solar storms, and definitely human-driven climate change are stressing the system today.
So what's the point for, someone listening right now? Why care about something 1 billion years away?
Well, I think it gives incredible perspective, doesn't it? Understanding that even planets have lifespans, that habitable conditions are finite. It's humbling. And maybe, just maybe, it underscores why dealing with the environmental pressures we can control right now is so vital. It's about appreciating and protecting the habitable window we have.
Yeah, that makes sense. So while we're all wrapped up in our daily stuff, these huge cosmic timescales just roll on. It's quite something to think about, isn't it? What does it mean to even consider an expiration date for life itself?
Deep thoughts.
Indeed. If you're enjoying this exploration, definitely hit that like button and subscribe for more adventures.
Subscribe for more discoveries. And let us know your thoughts on this. Share them in the comments.